Okay, this is a document that I'm going to send to you just as a picture because it'll probably be worthwhile to look over it on your own. But it's about how to factor polynomials, and there's no secret to it. There's no technique that works every time, so you're going to have to try a few things. Off on the side here, I've written that not all the polynomials can factor. Some of them are prime. The ones that will ask you to factor in Math 10, they're definitely factorable. It would be really mean to give you a trick one that you couldn't solve in Math 10. So always factor out that GCF. There's no reason not to try. If there is one, it'll make all of the rest of the steps easier. If there isn't one, oh well, at least you tried. So always try to do that. If you can't, you can't. But if you can, you'll have made your life a bit easier. After you have factored out the GCF, you can check a few different things, and none of them are necessarily going to be the right ones to check. It depends on the circumstances. But you might want to check for any of our special cases. We've memorized 3 of them, and that is if you take a minus b, square them, it'll always turn into a squared plus 2 times the product of a and b. That's not right. I've got my signs mixed up here. This is a plus and that's a minus. So if you take a and b, a plus b squared, that's a squared twice the product of a and b squared. If you have a minus b squared, that's a squared minus twice the product of a and b minus the root of b. No, plus b squared. 2 mistakes there. And if you have a plus b times a minus b, that's the same as a squared minus b squared. So if you notice anything on the right that looks familiar to what you got, or anything on the left that looks familiar to what you got, that's always going to be a clue that you should probably flip it from one form to the other, or maybe at least worth checking out. If you see that, great. That's probably what that question was about. If not, you've got choices. You could try breaking your polynomial, whatever it is, into groups. And those groups might appear naturally. Like here, if we have 4x squared minus 10x plus 6x minus 15, I might say, okay, this purple group here has a common factor of 2x. I can pull that out from this term and that term. Or I might say that this red grouping here, 6x minus 15, has a common term of 3, common factor of 3. I could pull that out of both. And what you're hoping for here is to find something like 2x minus 5 and 2x minus 5 left over after you've pulled out your common factor. That's the same in both. That's probably what you're looking for in a situation like this. It's probably what we're going after in the type of problems we're doing in Math 10. And if you find that, that's great. You take that and that, your 2x minus 5s that you found that were the same. You write it once, there. You take your outside factor, your common factor from before, your common factor from after. So the purple group and the red group, 2x and positive 3, you write them in there. And you have factored this. You can always and should always check by foiling. So taking your first terms, your outside terms, your inside terms, and your last terms, finding all those products, combining like terms. Make sure you get back to the same thing as you started with. If you have something that doesn't make nice groups, like a trinomial, one technique you might need to do is make your own groups. So here, 4x squared minus 4x minus 15, you can take negative 4x and split that into anything you imagine, really. And that's a frustrating step because anything you imagine is not necessarily anything the problem writer imagined, but I can't help you there. So instead of writing negative 4x, I could write negative 10x plus 6x, which I really just stole from over there. Because it's still the same value, negative 10 and 6 gets you negative 4. And once I have a group, once I've split that middle term up, I might be able to make a group here and a group there that I can play the same game with as before. This is potentially quite frustrating because you got to try and see if it works. Maybe you can find it, maybe you can't. If you can find it, great. If you can't find it, that either means that it's not a good technique or that you just didn't happen to see it right now. Wish I had better news for you on that front, but you're going to have to just kind of like check. If you're dealing with a trinomial, there's going to be two ways it might look. It might look like this, x squared plus bx plus c, where this number here is a 1, right? It's invisible, it's not written out. So just like x squared or a squared or b squared or whatever. No coefficient in here. This is good. This is the easier of the two cases. And in that case, what you do is you take your last term, your constant term, factor it. So 12 could be 1 times 12 or 2 times 6 or 3 times 4. Write out those factors of 12. And you're looking for a group of them, so one line's worth, where you can get them to add up to the middle term. So 8 in this case. So 1 and 12 is 13, no good. 2 and 6 is 8, that's great. 3 and 4 is 7, that's no good. But 2 and 6 works. So we would take the factors of x squared, or just x and x. So that's x and x right there. And we take a 2, throw it in one of those brackets, a 6, throw it in the other bracket, and that's that trinomial factored. Always check with FOIL at the end. It's quick to do, and the more times you practice with FOIL, really the faster it gets. If you have an a term here, a first term, a leading coefficient that is not a 1, so it could be like 2x squared or 5x squared or negative 20x squared or whatever, then you'll probably have to try a few times. You're going to need all the factors that make up your constant. You're going to need all the factors that make up your leading coefficient. All the factors that make up your leading coefficient will go into these spots here. So we've got our two brackets that we're trying to multiply two binomials. And the leading spot, the first spot, that this guy here and that guy there, that's where your factors of A will go. All of your factors of C will go into the last spots here. And that's what we did in this example. Our factors of C went into our end bits there. And you just got to try. So you try all the different combinations you can make of all the factors of A and all the factors of C. And I'm going to show you two techniques about how to show your work there. And I'm going to do that in a separate video, so these videos stay short. But no matter what you do after you try all those combinations, it is a great idea to keep checking the results with FOIL. You know you've got it right when you can go backwards and get to where you came from.